Good morning, students. Students, good morning.
Good morning.
Good morning, sir.
Good morning.
Have you solved the questions on dimensions?
Yes, sir.
Whatever books you have, any doubts are there?
No, sir. So, but previous vector worksheet, I have some.
Yeah. We'll do that tomorrow evening. Okay, tomorrow will be longer class. We'll do it. Okay. Now, after doing this units in dimension, we are moving on to kinematics directly. Okay. In between, there is errors and measurement also. But I feel like let me arrange the two instruments, screw gauge and vernier calipers. Okay. Once we do that measurement thing, then we'll go for errors so that you can understand it in a better way. Okay. So maybe expect we'll take in a day or two. Okay. So we'll do that. But meantime, we are starting kinematics. So if you say the actual physics starts from here, we can say that. Okay. So starting kinematics. Okay. Put the heading as the chapter is kinematics. Kinematics. What is kinematics? The study of motion. Okay. Study of motion of object. Study of motion of object. Okay. Without taking into consideration who is responsible for motion. Okay. We are only going to study motion. Who has given the motion? We are not bothered here. Okay. Kinematics is that kind of branch of physics in which we are not taking into account who is responsible for motion. Only we are going to study motion of part. Okay. The study of motion of object without considering the reason of motion, without considering the cause of motion. Without considering the cause of motion. That is the definition of kinematics. Right? Simple definition, note it first. Study of motion of object without considering the cause of motion. Right? Done?
Yes, sir.
Okay. Kinematics is the topic name. Okay, chapter name. It's not a subtopic of the chapter. It's a topic name. In kinematics, the first thing that we are going to study is frame of reference. Very important this is. Frame of reference. What is this frame of reference? See, if I say that I am at the moment at rest, I am not moving, I am motionless. So the question will be asked to us. You are motionless, okay, but with respect to what? Say with respect to ground. With respect to ground, I am not moving. Why this with respect to ground is required? Because you can be rest inside the car also. In the car also, you are going and sitting on the seat. Are you moving inside the car? No, you are sitting on. Right? So you are at rest in the car, but actually car is moving. So person on the road is seeing that you are moving. You are going ahead. But another person who is in the car, he says you are at rest only. Because your position is not changed. Right? Understood? Same way, suppose you are in elevator, that means lift. You are going up. The person on the ground is seeing that you are in motion because lift is going up. Another person in the lift is saying you are standing at rest only there. Because with respect to him, you did not move at all. So you are at rest with respect to a person in the elevator, but you are in motion with respect to a person on the ground. So if you are in motion or you are not in motion, who will decide? Something has to be there. Who will decide it, right? And that is called frame of reference. Okay, something like origin. Okay, origin's work is what? Origin's work is so that you can measure a particular distance or measure or see particular position of the object. That's why we require origin. If origin is not there, then what will you do? You cannot measure, right? So that's why the work origin does in the geometry, in the coordinate geometry. Same kind of work here, frame of reference does, so that we can find out whether the object is in motion or at rest. Understood? So frame of reference is what? A reference through which it can be determined whether object is in rest or motion. Object is in rest or motion. Okay, write this definition. Then with the diagrams, I'll try to explain you what I explained you orally right now. Okay, do that fast. Done?
Yes, sir.
Okay, right. So what is called reference frame? What is called observer? One thing is there. Observer is also there. One is reference frame, another one is observer. Both are required. So see now. Let's take an example here. Okay, this is suppose one path, road is there. Okay, and in this road, let's keep one car here. Okay, like this car is. In the car, let's say there are two people. They are sitting. Okay, these two are sitting in the car. And there is a person here on the ground. Say this is B and this is C. And let's say car is moving with velocity V, with speed V. It's moving. Right? So we said that whether the particle is at rest or motion, for that reference frame is required. Okay, fine. Now when we say three people are there, I would say a person B is moving with respect to ground. With respect to ground. That means car is moving on the ground. Okay. Who is seeing it? This person. And is observed by person C. And is observed by person C. Observed by person C. Okay, so car is moving on the ground. We know that now. Why? Because he is seeing it. Who? C. Where is he? He is on the ground. That's why he can say that with respect to ground it is moving. Okay, so who is he? This is observer. This is observer. And this ground is frame of reference. This frame of reference and this is observer. Okay. Second one now. Second one. We will say this B is at rest with respect to A. It's not moving at all. Because both are inside the car, no? So we'll say that a person B is at rest with respect to car. With respect to car. Why? Because he's moving along the car. Okay. Is he have any motion inside the car? Is he moving from one seat to other seat or sidewise or here and there? No. He's sitting and the car is moving. Right? So he is at rest with respect to car. Who is observing it? Person A. Okay? A person B is at rest with respect to car and is observed by person A. Okay, this person A is observing it. So now who's the frame of reference in this case? Car. Car is the frame of reference. This is frame of reference. And this person A is observed. So does it mean that, is it necessary for us to have a frame of reference to define rest or motion? Absolutely. Without frame of reference, we cannot determine whether the object is at rest or in motion. Is it clear, students?
Yes, sir.
See, in both the cases that I have written about the same person. Who is that person? B. Okay. So with respect to C, he is in motion, but with respect to A, he is not moving. Right? So that's why I'm saying from every frame of reference, the things are different. Like if suppose I say that I am at rest right now, I'm standing in front of you, I'm not moving. Okay, you are also able to see that I am at rest. But if you go on some satellite which is orbiting around the earth, which is moving around the earth, and you are seeing from the satellite, that the person in the satellite will say that I am in motion. Okay, he will say I am in motion. How? Suppose, let's take one example, more example I will do. Suppose here, two parallel tracks are there. Two parallel tracks are there. And this person here, maybe let's say a person D is here. Okay, he's at rest, he's not moving. He's not moving with respect to ground, he's at rest. Okay. Suddenly a car comes. Okay, car is going like this, a truck is going like this, let's say. And inside this one person is sitting. Let's say that person is M and car is moving. So when he sees this person, this person is seeing this person. So what will happen? He will see that that person is going back because this truck is moving ahead. So what he will see? This person is moving back. Similar to what happens whenever we go in train, we see outside in the window. What happens? All the trees will be going back. Are trees going back actually? No, you are moving. But what you are seeing the trees are going back. That means trees are having motion with respect to you. Why? Because you are in motion. Okay. So tree actually is at rest. This person is at rest actually. But because truck is moving, he feels like this person is moving backside. So that means D is in motion with respect to the truck. We'll study it more. Okay. Are you able to understand what I am explaining right now?
Yes,
Students,
sir.
everybody? Is
Yes,
everyone
sir.
getting it? Okay. First note that, first and second point, then we'll discuss it more. Done?
Yes, sir.
Yes, sir.
Okay. Now we need to study what is the meaning of motion and rest. Said already motion and rest is there with the reference frame required and all that. But what is motion basically? Motion and rest. Okay, what is motion? When we will say that an object is in motion or a person is in motion, we say that a person or object is in motion if its position changes with time. Okay, if its position changes with time, then we can say that yes, this particular person is in motion. Then again, to change its position, what we require? Origin is required. No, origin is again reference frame. Frame of reference is only origin because you need to see the positions. So can origin be different and different? Yeah, when frame of reference changes, then origin also changes. Okay, so what is the basic definition of motion? When the position of a particle changes with time, we say that that particular body or particle is in motion. Simple definition. Then you try and understand it more. Okay, when position of particle changes with time, then the particle is said to be in motion. Said to be in motion. Okay, so let's consider an origin. With respect to origin, only we see this. Coordinate system. This is x-axis, and this is y-axis. Okay, there is a particle here, right? Particle A, or a particle is there at position A, whichever you say that. Now this particle has started moving and it moved like this. So it reached at position B. Its position changed? Yes. That means it has moved. It was in motion. What is the position? How we check? Check it from origin. Join this one from here. That is called position. What we call it as position vector. This is OA and this is OV. Okay. Particle has moved from A to B. Its position has changed. That means it has moved. That means it was in motion. Okay. Particle changes its position from A to B. From A to B. With respect to, what is that? O. With respect to O. O means what? Origin. Okay. With respect to O. Hence, what I have written, particle changes its position from A to B with respect to. Hence, particle has moved from A to B. That means it had motion. So whose frame of reference here? XY coordinates. With respect to O you are observing. This is frame of reference. In the frame of reference, are you moving? Yes. From where you are observing? From point O. Okay. The body is in motion. The same thing we would have done in moving frame then. We'll discuss it. First you note. First you note this.
Completed.
Right. Okay. So if I make it something like this to explain you, suppose this is Earth. What happened? This is Earth. Okay. And on this Earth, we are standing. We are standing here. Where? Here. Okay. And there is a satellite which is moving around the Earth. Right? The satellite is here. There is a satellite. It's moving like this. And this is our Earth. You are at rest. Okay. You are not moving. You are at rest. Right. So with respect to Earth, our coordinate system is within Earth. And we'll say you are at rest. Okay. But when you are seeing from the satellite, you will see that this person is in motion. What is the meaning of that? Can we define anything as absolute rest or absolute motion? Can I say this object is at absolute rest? Answer is no. It's not possible. I am standing over here. With respect to moon, I am in motion. With respect to satellites, I am in motion. With respect to another planet, I am in motion. Okay. So I cannot be at absolute rest. Absolute rest means you are at rest with respect to all the frame of references. That's not possible. What does that mean? It means is rest and motion are relative. They can only be related. That means in a particular frame of reference, I can say you are in motion or you are at rest. I cannot say that your motion is absolute or your rest is absolute. It's not possible. You will always be moving with respect to some other frame, or you will be at rest with respect to some other. Okay, understood that? So if the positions are changing with respect to any frame, we can say that you are moving in that frame. If with respect to another frame, your position is not changing, you will say that you are at rest with respect to that. So different frames are possible. Yes, different frames are possible. A frame can be a frame which is moving. Okay, a frame can be, you can say that frame is at rest. Possible. Whichever frame you want to take, accordingly we can define the rest and motion of any particle. Okay. So what I am trying to explain you over here, rest and motion are absolute terms. Sorry, are relative terms. Are relative terms. There is no absolute motion or rest, as particle can be at rest with respect to one frame, but can be in motion with respect to other, with respect to one frame, and can be in motion with respect to other. Okay, example, this field, right? Okay. What is the example here? Person on earth feels he is at rest, but same person is in motion with respect to satellite. With respect to satellite. Okay. So rest and motion are what? Relative terms. One object is at rest, Here, same object is in motion somewhere else. Okay, so both are relative. It's confusing. Are we going to study in this way? No, we will not study like this. We will study everything with respect to ground. Why? Because for us, ground is at rest. That means Earth is not moving for us. We don't feel it. If it's moving also, we don't feel it. We know it's moving. Do we feel? So for us, Earth is at rest. So we will study everything with respect to Earth. So no need to worry. But actual definition of rest and motion, we should know. That's why we are studying all. Note it. This is what satellite. Okay. Done?
Yes, sir.
Everybody, shall I move ahead?
1 minute, sir.
Okay.
Completed, sir.
Right. Now in this kinematics, what are we going to study? We are going to study straight line motion. That means I'm not going to change the direction. You will move straight. Okay. No change in direction here and there. I'm not going. So we call it as 1D motion. 1D means one dimensional motion, in which only one coordinate will change. Either x coordinate will change or y coordinate will change. Both will not change at the same time. Okay. Only one coordinate will change. What are we going to study? Straight line motion. Called straight line motion, or you call it as 1D motion, or we can say the path in which only one coordinate changes. This also sometimes is not correct. When we can have two coordinates also, we can change. So don't write this coordinates. Don't write this. One dimension motion, straight line motion. Why I'm saying it? Because there is a possibility that you don't travel along x-axis, you don't travel along y-axis, you go in between. Possible, not possible. This is x-axis, this is y-axis, and I am not moving along x-axis. Let's say I am moving like this. Then what will happen? X and y both are changing. But still it is straight line motion because I am moving like that. Who's going to stop? I am moving in straight line. I am not changing the direction. Okay. So we call this as what? 1D motion. Still it is one dimension. Yes, it's one dimension because it's a straight line. If the motion is straight line, we call it as 1D. Okay. If motion is a curve, now I'll tell you that. Okay. Two dimensional also, so that you can understand. Two dimensional means your motion is like this. This is 2D motion. Curve is there. or you are moving in circular motion. This is 2D, two-dimensional. That means whenever you are having curve, okay, the direction keeps on changing. Here is direction changing for us? No. Is here direction changing? Yes. We are moving like this. Then here continuous change is there in direction. This is 2D motion. Or you call motion in a plane. Motion in a plane. Here is what? Motion in straight line. Okay? Motion in straight line. It's called 1D. Motion in a plane is called 2D. Then what is 3D? 3D motion is there in which more than one plane is involved. Here is only one plane. If more than one plane is involved, then it will be 3D. Are we going to study 3D motion? No. We don't have 3D motion. Is it possible? Yes, it's possible. Why not? How? Suppose one particle is moving like this here, like this, and then suddenly it changed the plane, came like this. And then it went again like this. This is 3D. It changes the plane. This is one plane. This is XY plane. From XY plane, you went on to the other plane. You went like this, and then suddenly you came back. This is 3D. When you have different planes. Okay. So motion in different planes. It's called 3D motion. Okay. Some books they will write it if there is a change in 2 coordinates, then it's 2 dimension. Wrong, that is. I'm changing, no? 2 coordinates here. Still, I am saying it about 1D motion or straight line motion. Okay. So it's not necessary that X and Y coordinates both are changing. It will become 2D motion. No. If it's a straight line motion, it's 1D. If it's a curved motion in the same plane, 2D. Motion in different planes, 3D. Is it clear? Note that one. Done?
Yes, sir.
Okay. I'm going to ask you one question. Okay. You tell me the motion is 1D, 2D or 3D. Okay. So here it is. Then, okay, one more time. Instead of making one more time, why not take this itself? Huh? Okay. Right. Okay. Let's join this. Okay, I have colored it because so that we can see it clearly that the back side one is actually orange and the front side is white. Okay. Now what? I am saying you that we are moving from this point here to this point. Okay. Let's say this is A. Okay, let's Mark it. A, B, C, D, E, F, G, and H. Okay, you marked it. We are moving from A to F, like this. Here coordinates are what? 0, comma 0, comma 0, because this is x-axis, this is y-axis, and this one is z-axis. So 0, 0, 0. And maybe here your coordinates are x, comma y, comma z. You move from A to F. You have to tell me it's straight line motion, it's a curve, rather, it's a 1D motion, 2D motion, or 3D. Motion from A to F is option A, 1D, option B, 2D, option C, 3D, D, information not sufficient. Information is not sufficient. Okay? Tell me fast. 1D, 2D, 3D. All three coordinates are changing. Yes, GV, what is the answer?
Sir, is it 3D, sir?
Okay, GV's answer 3D. Adarsh, what's your answer?
Sir, 3D, sir.
Okay, okay. Vishnu,
3D, sir.
Sayan,
3D, sir.
1D. It's a straight line or not? Path is a straight line. Is its direction changing? No. It's a straight line path, 1D motion. That's what I tried to explain you. What I told you. This is 1D motion. Straight line motion is 1D motion. Curved motion in a plane is 2D motion. Curved motion in different planes is called 3D. Is it a curved one? No. A straight line. It's 1D. Are you getting the point? Even though three coordinates are changing, isn't it straight line? Straight line means 1D. Are you able to understand? Whether one coordinate change or two coordinate change or three coordinates change. If the motion is straight line, it will be called as 1D. Is it clear to you?
Yes, sir.
Yes,
Yes, sir.
sir.
Everybody?
Yes,
Yes,
sir.
sir.
Good.
Yes, sir.
I'll write it again, okay, one more time. What is that point? If the motion is straight line, then it is 1D motion, even though all three coordinates are changed. Okay? If the motion is straight line, it is called 1D motion. Even if all the coordinates changes. Okay, note this point, then we'll move ahead. Done?
Yes, sir.
Okay. Right, boys? Shall we move ahead?
Yes, sir.
Now let's start with the first term in this chapter, kinematics. The first term is distance. Okay? You all know what distance is. You all have studied. Okay. Distance is what? The length of actual path traveled by an object. Length of actual path. Length of actual path traveled by an object. Okay? Length of actual path traveled by an object. It's called distance. Object is distance. Okay? Now, length of actual path, what kind of thing is this? Every time, whatever we travel will be distance only. Yes. Whatever we travel is called distance because we travel actual path. Whatever path we will travel, that is only the thing we have traveled. That is called distance. Okay. So, why we need to study distance as such? Because there is another term we have, displacement. So, we need to understand what is called distance and what is called displacement. Okay. Little more about distance then. What type of quantity is distance? We say it's a scalar quantity. Okay, it's a scalar quantity, it's not a vector. Direction is not involved. It's a scalar quantity. Right? It is a scalar quantity. Said okay. Fine. What is its unit? Now, two types of units we have studied. Two types of systems. One is SI and one is CGS. So, in SI, its unit is meter. And in CGS, its unit is centimeter. Fine. Now, suppose we went from A to B. But we didn't go like this. We went like this because road is like this one. There's no road. Here is actually what? The river is there and all that are there. Okay. And here there is a river. So you can't go. Okay. Here is a river. You can't go like this. You went like this. So what is the distance traveled? Distance traveled is the length of the road. This is road actually. Whatever road is there, you have followed the road. That is only the distance. Okay. So distance AB is what? Length of the road. Length of the path. That's what we have written. Length of actual path. Okay. This is not the distance. Distance is this. And it is scalar quantity. It is scalar. Why? Because you can see the direction change. Which direction you are going to take. So that's why distance has no specific directions. That's why we're calling as what? Scalar. Because you are moving towards B, no doubt, but your direction was never towards B. Are you going towards B here? No way. Your direction is B over here. No. Your direction is B here. No. Your direction became B only here. Okay. So there is no specific direction of distance. It keeps on changing because the path is changing like that. Right. So that's why it's called scalar quantity units. Note this.
So completed, sir.
Right. So we discussed distance. Now let's discuss the other thing. What is that? Displacement. Okay. What displacement is now? The displacement is shortest distance between 2 points. Okay. Shortest distance. Shortest distance between 2 points. Okay. Same diagram if you see. A and B. Now what is the shortest distance? Join A from B directly with a straight line. Straight line joining initial point and final point. That is called the shortest distance. Okay. Shortest distance 2 points means joining initial and final point. With straight line. Okay. So A to B, you join it with a straight line. This is called displacement. Okay. This is called displacement. Even though road is this only, you can't move here because your river is there. But still displacement is this only. Distance will be there because you can travel through road, what you can do. Okay. So displacement at times can be hypothetical also. And you can't travel it, then why you are writing this is a displacement? That's how it is. Shortest distance between 2 points only is called displacement. Can be hypothetical at times. When it can be hypothetical? When your road is actually changing directions. If suppose road itself is like this, then distance and displacement are same. No problem. But if the road is like this, then distance and displacement are going to be different. Distance will be more than displacement. If the direction is changing, if the road is having different directions, distance will always be greater than displacement. If there is a straight road without change in direction, then distance and displacement will be equal. They asked the question. They are going to see that. Okay. So shortest distance between 2 points joining initial and final point with straight line is called displacement. Okay, it's called displacement. Then what we can say? What I explained you, that only I am writing over here. If there is change in direction of the path, distance be greater than displacement. Okay, and if there is straight road or there is straight path, there is no change in path, then distance will be equal to displacement. Distance is equal to displacement. Okay, note that one. Any doubt is there? Ask me. Done?
Yes, sir.
So,
Okay. Now in the same thing, you see that when we are talking about displacement, is it a vector quantity? Yes, it's a vector quantity. Why? Because it is always have a direction from initial point to final. Okay, so displacement is a vector quantity. Displacement is a vector quantity. What is its direction? Initial point to final point. It's always directed towards final point. Towards final point or destination, whatever that is. This is the destination from A to B. Okay. Displacement in the diagram is vector AB. Vector AB. It's a vector quantity. Okay. Displacement is a vector quantity. It's always directed towards final point. Displacement in the diagram is vector AB. That means what? What is that? Position vector of B minus position vector of A. Okay. Position vector of B. That means final position minus initial position. Position vector of B minus position vector of A.
Sir, what is meant by position vector?
Wait. We'll do no. We'll solve the problem. We'll understand. Wait. Okay. Position vector of B minus position vector of A. Okay. Note it.
Sir, completed, sir.
Okay. So this position vector thing we'll try and understand. Okay. Now suppose I'm showing you a coordinate system. Let's make it as a question. Okay. Showing you one coordinate system. And this in a plane, so that means two coordinates I'm going to talk about. Let's say its initial position is A and its coordinates are x1, y1. Okay. And from A, I move to B. X2, y2. I move from A to B. Okay. I have to find displacement vector. This is how I have moved. I want to find what? Displacement in vector form. That's our question. What is displacement AB? What we have to do? Little while ago, we understand that displacement AB basically is position vector of B minus position vector of A. How to get position vector? You have to join this point with origin. Okay, so this is position vector of A and this is position vector of B. Okay, this is position vector of A. Position vector of A we call as OA and position vector of B we call as OB. What these are, we'll write it. So position vector of B. Can anyone tell me what it is? Its coordinates are 0, 0, you know that. This is origin. What is position vector of B? Who will tell me? Yes, others, what is it? Forgot. Huh?
Sir, yes, sir. Forgot, sir.
Forgot. Okay. Sayan, you tell me.
Sir, can you give me 1 minute?
Sure. GV, what about you?
Sir, can you repeat it?
Position vector of B. What will be position vector of B? That's it. Everybody forgot. So simple it is. X2 minus 0 I cap plus Y2 minus 0 J cap. This is called position vector of B. X2 I cap plus Y2 J cap. Able to recollect?
Yes.
Yes, others?
Yes, sir.
Now tell me position vector of A then. Tell me fast.
X1 minus 0 I cap
Okay.
plus Y1 minus 0 J cap.
Okay. Final.
X1 I cap plus Y1 J cap.
Right. Clear, Vishnu?
Yes, sir.
Vishnu, you have downloaded app, right?
Yes, sir.
Okay. In the app, you go to video section.
Okay, sir.
Okay. In video, you will see there are vectors. Okay.
Okay, sir.
Click it. You will see all the classes on vectors there.
Okay, sir.
Okay. You go through them. You will understand. Okay.
Okay, sir.
Like
Yes, sir.
what I am taking, like this class, no? Same class is there.
Okay, sir.
Okay. Right. So position vector of B is x2i plus y2j, and position vector of A is x1i plus y1. We got position vector. But I have to find displacement, no? What is displacement? Displacement is position vector of B minus position vector of A. Okay? So that means it is actually what? OB minus OA. Simple. What is there in it? This minus this. This minus this is what? X2 minus x1 I cap plus y2 minus y1 j cap. So that's simple. Displacement over. If it's magnitude I have to find, that's a different thing. I'll give you the value, then we'll find instead of going over it. Or first you note, here also I'll do, there also I'll do. All right. Note it. Note it. Done?
Yes, sir.
Okay. So let's talk about the displacement amplitude here. So since it's given in INJ, we know that how to find the displacement magnitude. So AB's magnitude will be what? Square root of this is square plus this. Okay. X2 minus X1 whole square plus Y2 minus Y1 whole square. As simple as that. Done. That's the magnitude value. Okay. This is the value of displacement. And unit, did we discuss about unit of displacement? No. What is the unit of displacement? Meter only. Okay. So unit of displacement is meter. SI, meter, and CGS is again centimeter. Okay. So unit is same as distance, right? Note this one. Then I am giving you a problem. You calculate the value. Okay. Done.
Yes, sir.
Okay. Same question. I am repeating it. Okay. But with values. Same coordinate system. Here is a point. Let's say its coordinates are 2, 3. And another one is here. Another one here. That's D. Okay. And its coordinates are 5, 7. Okay. This is also meter. This is also. The particle has moved from A to B. Okay. Particle has moved from A to B. My question is find displacement A. That means magnitude. Okay. Come on. Calculate it fast.
Sir, is it 5, sir?
Yes, sir. Is everyone able to calculate?
Yes, sir.
Okay. Vishnu, are you able to calculate?
Yes, sir.
Good. Displacement AB. Sign?
Yes, sir.
Good. OB minus OA. OB means 5I cap plus 7J cap. OA means 2I cap plus 3J cap. Then 5 minus 2 is 3I cap, 7 minus 3 is 4J cap. Very good. So this is the displacement vector, 3I plus 4J. Okay, now what do we want? Magnitude. Okay, magnitude is what? Square root of 3 square plus 4 square, that is 5 meter. Okay, this is how we calculate displacement vector. And finally, the value of the displacement. Okay, fine. So I'm moving next. Next, what we want? Difference between distance and displacement is what? A very common question in 9th standard. Okay, write 3 differences between distance and displacement. Right? So, difference between distance and displacement. Vector and scalar we have already seen. So, that difference we are not going to count. Okay, you have to tell me some other differences. Vector scalar already over. Units of meter and centimeter, that's already over. Some other things you have to tell. What are those? Come on, think and tell me. At least one.
Sir, distance can be 0, sir, but displacement can.
Good. Say again. Say again. What you said, say again. One more time.
No, sir, sorry, sir. By mistake, I said it wrong.
You said the opposite thing. Okay. No issues. Okay. First point. That only I am writing. Okay. You said that, then only. Now suppose that a particle particle started from here, from this point, like this. Okay, particle started from A, went like this and came back to A. Came back to A. So displacement is how much? 0. Okay. If particle starts from A and reach A again, then what is 0? Displacement. Then displacement of particle is 0. Displacement of particle is 0. Final position vector, initial position vector is same. So displacement 0. But what about distance? Distance is actual path traveled. You have traveled or not traveled? Yes, I have traveled. Distance is there. Okay. If particle starts from A and reach A again, then displacement of particle is 0. But distance is length of actual path traveled. Actual path traveled. That is not 0. If suppose its radius, I would say, is r, then distance traveled is 2 pi r. So displacement can be 0, distance cannot be 0. That's first point. Okay. Displacement can be 0, but distance can never be 0 if particle has moved. If there is motion, particle. Okay. If the particle has moved from its position, distance traveled can never be 0. If it's at the same place only, then we cannot say anything. But if it has moved at all, then distance can never be 0, but displacement can be 0 if he comes back. That means you went in the morning to school and returned back at home in the evening. Your displacement 0. But distance, while going, some distance you travel, while coming back, distance you travel. Addition of both, that is the distance you did. Distance you traveled, but displacement. This is first point. Is that clear?
Yes.
Right? But if it was straight line, then? If it's a straight line path, then distance and displacement will be equal. Yes, Vishnu, you are asking something? Vishnu, you are asking something?
Sir, no, sir. I told understood.
Okay, right. Note this first. Done?
Yes, sir.
Yes, sir.
Okay. There is one more. In addition to this only, what is that? Displacement can be negative also. Zero you saw, displacement can be negative also. How? Displacement can be negative. Distance? No way, it cannot be zero. How can it be negative? Okay. Displacement can be negative. Shall I write for distance also? Distance can never be negative. Okay. Distance can never be negative. Shall I write it separately? Take it. Distance can never be negative. How displacement can be negative? See, if suppose this is our starting point or origin, you went like this, then you turned, and then finally you went like this. Okay, this is your position. Then displacement is negative. Okay, this side, suppose you traveled 5 meters. This is 5, and then this direction 3 meters. Okay, so this is 3. Let's assume. So your position will be minus 3. Displacement will be minus 3. Okay. If we say this is x-axis for S and this is y-axis for S, then displacement, what I'll write, minus 3i. Distance 13 meters. 5 meter, 5 meter, 3 meters. Distance is 13. Understood that? Is it clear?
Yes, sir.
Note that one also. So displacement not only can be 0, but it can be negative also. But distance can neither be 0 nor negative. Done?
Yes, sir. Done.
Okay. Combining both, one difference I am writing. Combining both. What is that? Combining is magnitude of displacement. Displacement's magnitude is always less or equal to distance. Okay, we saw 0, we saw minus 3. Minus 3's magnitude was what? 3. 3 was less than 13, right? So displacement is always less or equal to distance. When it can be equal, I've written equal also possible. When it can be equal?
Most on the straight line.
No
Straight
change,
lines.
no change in direction, straight line path. Okay, both are equal on straight line path. Straight line path when particle does not change its direction. Does not change its direction. Okay, and other than this, there's only one difference. We discussed it although still I'm writing it. Okay, the main difference is displacement does not depend on path. It's path independent, whereas distance depends only on path. That means road. Okay, the displacement is independent of path. Independent of path. Whereas distance depends on path. Okay, note this one. Done?
Yes, sir.
Okay, so distance and displacement theory part is over. Okay, and our class is also over, right? Next class, we are going to enjoy more. Because now we'll start understanding physics in a better way and we'll start doing numericals on the theory part that we are pushing. Okay, tomorrow's class, we'll have that. Right? Okay, see you tomorrow then. Bye-bye, students.
Thank you.
Thank you, sir.
Thank you, sir.